To look at now, like I said, called the master gland. It's attached to the base of the brain. There's a little stalk called the infundibulum, and that's what holds the pituitary. So it's almost like a grape. Like your pituitary is the little grape, the infundibulum is the little stalk, and then that connects it to the hypothalamus, which is part of your brain. There's two parts, the anterior lobe and the posterior lobe, so the front part of the pituitary and the back part of the pituitary. The front consists mostly of glandular epithelial. It's in a capsule of collagenous connective tissue. The back is more nervous tissue, so it's going to have nerve fibers, neuroglial cells that support it. So the front is more epithelial connective, the back is more nervous tissue. So here's just a picture of it. Here's the little stalk that it sits on. So if I'm looking at, the head is facing this way, this direction, this is the front, this is the anterior, it's a little bit larger. This is the back, it's the posterior. Lots of connective tissue, lots of nervous tissue. The hypothalamus, like that diagram, controls the activity of the pituitary gland. So releasing hormones and inhibiting hormones from the hypothalamus control what happens in your pituitary. The hormones are carried to the bloodstream. There's actually veins that attach directly to your pituitary gland, and those are called hypophyseal veins. So these are the veins that attach directly to your pituitary gland. And then specific cells are stimulated to release or stop releasing their hormone. So once this hormone goes to the target cell, the place that it's supposed to go, then that's going to stimulate another release of hormone. The posterior pituitary mostly stores hormones that are made in the hypothalamus, and then they will directly release them also into the bloodstream. So the front, the anterior pituitary gland is going to send messages, send some hormones. The posterior stores hormones, and once they receive impulses from the hypothalamus, they are going to release their hormones. This diagram won't be on the test, but just interesting to see how these blood vessels surround or are located directly on the pituitary gland. Some of the important hormones from your pituitary, growth hormone being one of the most important. Growth hormone stimulates body cells to promote growth and reproduce. It also speeds up the rate that cells will use carbohydrates and fats, so it does affect your metabolism as well, but its main job, its main peak is during your growth spurt. People who maybe their genetics are very, their parents are extremely short, or possibly they have a disorder, they can be prescribed growth hormone so that it will stimulate growth in their body. The growth hormone releasing hormone is what basically stimulates the growth hormone to be released. So remember we said when we're looking at the anterior pituitary, the hypothalamus is going to release a hormone, and that's going to affect the releasing of other hormones. Growth hormone release inhibiting hormone is going to then slow it down. So GHRH, release growth hormone. GHIH, slow down growth hormone. Nutritional status also affects your growth hormone. So if your nutrients are not where they're supposed to be, your body will try and fix that and actually stimulate more growth hormone released so that you do not stunt your growth. Imbalances. Some of these are on your list, so some of you might be researching one of these. Pituitary dwarfism, deficiency during growing years. So I don't have enough growth hormone, I'm not going to reach my potential. This is where growth hormone can be prescribed to somebody. Gigantism, oversecretion during growing years. There the body secretes extra growth hormone, and here you can have people that reach extreme heights and things like that. Acromegaly is oversecretion during adulthood. So this doesn't happen during your growth spurt. This actually happens when you're done growing, and it happens during adulthood. Prolactin, PRL is the abbreviation for that, promotes milk production following the birth of an infant. Typically no known physiological role in males. This is for females. And notice this happens following the birth. If you're around animals at all, you'll know that like cows produce colostrum first. Their milk is rich in colostrum before they actually produce a lot of milk. Same thing happens in women. After you have a baby, the breast tissue doesn't instantly produce large amounts of milk. There will be a little bit of colostrum that's released, and then I would say on average 3 to 4 days after the baby's born, then there will be normal release of milk production. TSH, thyroid stimulating hormone, also very common, very important. Controls secretion from the thyroid gland. So thyrotropin releasing hormone, TRH, this also comes from the hypothalamus, is going to regulate, that's what regulates the production of TSH. As blood concentrations increase, then secretions are going to decrease. So here again, negative feedback. If I have enough TSH in my bloodstream, secretions are going to decrease. Your thyroid is going to pick up on that. And here you can just see the diagram. So thyroid is in your neck region. Pituitary gland sends information. It's going to be carried in your bloodstream. And like I said, it's negative feedback. So if I have enough TSH in my bloodstream, the thyroid is going to say, slow it down. I don't need that much in my bloodstream. Adrenocorticotropic hormone, ACTH, controls the secretion from your adrenal cortex. So that's where the adrenal comes from. The worksheet that I had sent out with all of your lists of hormones and what they affect, this one is on there. Here again, everything is going to be regulated by the releasing hormone. So corticotropin releasing hormone is what's going to regulate it. The other thing that can stimulate this is too much stress. So stress in your life can increase the release of this adrenocorticotropic hormone. Gonadotropins, these you probably should have heard about in biology, FSH and LH. Very important in both males and females. Follicle stimulating hormone, luteinizing hormone, affects testes and ovaries. So follicle stimulating hormone, very important for production of eggs, production of sperm. Luteinizing hormone is going to peak in females at different times during their menstrual cycle. So I'm assuming that you've at least heard these terms before. In males, LH is also called interstitial cell stimulating hormone. Not so concerned that you probably know that, but this part here you should know, because that you should have had in the past. Posterior pituitary, ADH, antidiuretic. This deals with even water storage in your body. Oxytocin, very important in females, released in large quantities during labor. And impulses from the hypothalamus will direct when to release those hormones. And antidiuretic produces its effect by causing the kidneys to conserve water. So like I said, antidiuretic, very important with the amount of water that you have in your body. If you drink large amounts of water, your kidneys are going to filter that, it's going to run through, and you're going to go to the bathroom more frequently. If for some reason you are dehydrated, you don't have enough water in your bloodstream, the hypothalamus is going to tell your kidneys, hey, store some of that water. And then what you'll notice, sometimes you'll actually, like your fingers might swell, or like long trips and your feet swell. Your body is retaining water. If you eat too much salty food, your body will retain water and conserve it. Osmo deals with water. Osmoreceptors sense those changes in your body fluids, specifically your blood. This is not sugar diabetes. Diabetes insipidus is when the body does not produce enough ADH. So this would affect your water conserving levels, something completely different than your sugar levels. And oxytocin, like I said, very important in childbirth. Main function of oxytocin, should know this one. It is going to be the hormone that stimulates contractions. So if your body does not produce oxytocin, you're not going to have contractions, and you're going to have problems with childbirth. It also is the hormone that helps to stimulate milk letdown and allowing the milk to be available for the baby. During pregnancy, when the uterus stretches so far, that stretching is what stimulates the release of oxytocin. And when an infant starts to suck on the breast, that's going to stimulate a release of oxytocin. And this is the only one that is positive feedback. So when you go into labor, once this starts, your body produces more oxytocin. Once you produce breast milk, your body produces more. And the only way this will stop is when basically you force your body to stop feeding. And then a lot of times women will have problems with leakage of the breast and things like that, because that hormone is still being produced for a period of time. If you've heard of someone being induced with labor, a lot of times this oxytocin is not released at the right time, and the female may need like Pitocin, which is kind of a drug that simulates oxytocin, and basically that will put the woman into labor since the oxytocin is not being released. So if you hear of someone being induced for labor, often it's this hormone that is not doing its job for one reason or another. And there's the table. These are the hormones of the pituitary gland. Here's the front lobe, goes down to here. The bottom part is the back lobe. You can kind of see where they work and what they do. And it kind of puts it all together. And that's where we'll stop for today.